Cool. Hello everyone. My name's Lewis, and today my talk is going to be about diving into Reactive Streams. So as developers, we kind of work on software, and that software is normally abstraction on other pieces of software, and it goes down layers upon layers, abstraction upon abstraction. And kind of in this particular instance, working on an Akka Streams application, I got stuck with a kind of a scaling issue where I come across a bottleneck from scaling. And I kind of had to dig into like the abstraction beneath, which was Reactive Streams. So this is kind of like this talk is kind of like a journey into digging into abstraction, learning what's happening underneath, and then using that to kind of solve your current issue. So yeah, let me introduce myself. I've been at ClearScore for over 2 years. I'm working in the Office stack. So as part of the app that Ed was showing you earlier, it was where you click into the offers and you can buy like credit cards, loans, car finance products. And kind of my space is like doing the integration between ClearScore and the partners and kind of serving this back to the front end. I've been working with Scala for nearly 4 years. Love the stuff, love programming. I think we all agree on that here. Yeah, so the kind of structure of my talk today will be kind of going over the offline offers platform, or where the Akka Streams implementation was. It will be digging into Akka Streams. I'll give like a whistle-stop tour of how all the components work, and then looking into the issue, like what was the bottleneck, and then looking into how learning Akka Streams kind of helped me solve that, find what the issue is, and then just for the fun of it, as we're going to Akka Streams, and probably everyone's going to be like, why don't you use FS2? So we're also going to look into FS2 and make a comparison. Okay, so first into the kind of the context in which it was set. So this was a streaming platform, so streaming is like any sort of implementation that kind of allows you to deal with an unbounded amount of like entities to like process. So it could be like a WebSocket streaming, it could be streaming something from a file, but in this case it was streaming from a database. And so we were streaming data from a database, fetching offers, getting the offers back, and then sending events to the analytics platform, and then kind of updating the database with information from the offers. And how this looks, so then to give a little run through of how Akka Streams works, a very, very high level, is Akka Streams kind of works on kind of a graph basis. So you kind of construct your graph as a description of your code, and these are made up of certain components. And these components are your source, your flow, and your sink. And as you can see from the case classes on the right, you've got a source that kind of makes an output and takes a materializer. So what a materializer is in a bit. And then you have a sink, which is kind of on the other end of the stream. So this is like the terminating step, which takes an input, then also takes a materializer. Then you have a flow, so that's kind of thing that sits in between, like a source and a sink, and kind of takes an input, then also has an output, but then has a materializer as kind of like the runtime of the stream. That's what a materializer is. It's kind of, you have the graph as like the description, and then you have the materializer as kind of like how it should run and where it should run. I think in the most updated version of Akka that you can actually just use an active system instead of a materializer. But the active system kind of sits underneath the materializer. This kind of helps you schedule the computation on threads. So the active system spins up actors, which has like these are entities of like internal state. And these like use like a messaging, the active model messaging system in order to like execute computation on like JVM threads. And so this is what it looks like on the offline offers platform. This is kind of like a abstracted version, kind of getting rid of the query dependency and the database dependency. Now you can see on the top left here, this is the source from like a slip integration, and it's streaming a request to the rest of the graph. You obviously you've got the flow, you've got a few 4 sinks, and these are doing like updating to the database, logging a response, sending events, and then just terminating the stream itself. So you can see in the graph where it's all been put together, where you've got like this Akka DSL, which I think is one of the best parts of Akka, where you've got this little tilde sign, and it kind of shows the description of how all the graph comes together. So you've got from this one stream query going into a search, then this broadcasts out to 4 sinks, and kind of these all do separate things itself. That's kind of like the description of the graph, and then executes the run method, kind of takes the materializer, then runs the graph itself. So what was the actual issue? So we had this platform, it worked, it kind of worked just for like one stream, and that's all it was ever used for. It was kind of built like 4 or 5 years ago. And then when there's a business case of like, okay, what we're going to have like 20 streams or like 50 streams, we've got kind of like a business case for that, how that works. So testing it out, we got this kind of weird behavior where when you start up another stream, it would kind of start the stream up, and then after a few seconds, it terminated. And so like you're looking at like Grafana, looking at the metrics, you're seeing there was a scheduler behind all the streams, so if there was still entities to process in the database, it would kind of schedule it the next minute. So what you're seeing is like another stream starting up, and then suddenly terminating, and when the scheduler picked it up again, it would schedule it again, but after a few seconds it would drop it again. And this wasn't good. So we had to kind of like, what was it? And after exhausting all the kind of obvious things, it led me to look at the Akka docs, and there's a lot of information in the Akka docs. But then I came across like them describing Akka as an implementation of Reactive Streams. So it led me to look into like what is Reactive Streams. So Reactive Streams is kind of like a group of people from like streaming companies got together, like people a lot cleverer than I am, kind of made this contract and were like, how can we abstract all the stuff that we need from Reactive Stream and kind of make a streaming implementation that's kind of language agnostic, and we can work between like JavaScript on the JVM on like client side and kind of abide by certain like tenets, certain rules. So they created this Reactive Streams manifesto that kind of adhered to 3 tenets. So being able to process a potentially unbounded number of elements in a sequence, to asynchronously pass elements between components, and to have mandatory non-blocking back pressure as default. And as you can see here, here's some links to like kind of the JVM implementation on GitHub, and there's loads of them like easy way of reading. It's like this must have this, or it should not have this, and kind of it's like a contract. If you're going to do Reactive Streams implementation, this is what you need to have. So from this, I'll try and like superimpose Reactive Streams onto Akka Streams. And so that's trying to understand in the JVM on the Java interfaces, which anything on the JVM would like inherit these 3 Java interfaces. So you have a publisher, which then subscribes to a subscriber, and then on subscribe it takes a subscription. And then these are your 3 components. And once the on subscribe method has been like initiated, they need to kind of combine and kind of make a stream. And then the relationship and how like these communicate is also within these like class contracts. So a subscriber will be like, I have like space in my internal buffer, I have room to request some more. So you request how many entities you want from the publisher. The publisher will then initiate an onNext method in the subscriber, and kind of this will then say, here they are, you start processing them. And then as the subscriber runs down and gets to say half the buffer, it will then ask for X amount more, and kind of have this like feedback cycle. And then when the publisher has run out of like entities to process, it would naturally just initiate this onComplete method, and this would say, I'm complete, like, stop doing it, like, clean up all the resources, I'm done. And kind of put it all together, this is end up your Reactive Streams like looking like. So you have a publisher, and when a component is both a publisher and a subscriber, you then call it a processor in the Reactive Streams kind of manifesto. And so you've got this, after they've all been subscribed, like on subscribe, a subscriber will request for X amount, which will then request, and kind of have all like, and then it will go on next. And then after this is all done, it would be onComplete, and the whole like stream will then terminate. So how did that help me? So like I did a lot of digging. It's kind of like you go into a rabbit hole and you're like, is this even the right place? Like, what am I looking at? Where I've been hours on documentation. But then I started looking into the logs and found this. So these are like kind of the same sort of language and same contract that I was looking at in the Reactive Streams implementation, and found that you can see these requests like language saying send 8 elements, like send 0 elements, like this request and on next like language has been happening. But suddenly it said finishing streaming on complete. But then it was still more like entities processed from the database. And as you can see, the scheduler then a minute later kind of restarted the same stream and then started the stream again. And this kind of happened in cycles of starting up, terminating it, starting up, terminating it. But like what's happening here? And so yeah, this is what's happening. You have Slick Producer, you have these Akka processors, and Akka Subscriber. So this is kind of like superimposing Reactive Streams onto Akka Streams. And then what was happening is from the Slick Producer, so that's where this onComplete method came from. You saw this onComplete, and then it terminated the whole stream. So does anyone want to take a guess of what the issue was? Like, why was the Slick Producer initiating this onComplete method? Anyone hazard a guess? No one answers? It was, so I went through like the normal stream, like thoughts of like looking into like certain overflow strategies, like is it not back pressuring properly, and like did a lot of reading into overflow strategies. And then a colleague of mine, Hugo, who's here, was like, have you checked like thread pool salvation of the database thread pool? And I hadn't, so I looked into the Akka thread pool and checked that that had enough threads, but the database had its own thread pool, and only had 3 threads in the thread pool. So what was actually happening was, as the stream was started up, and as like a connection to the database normally consumes 1 thread, and it's quite a blocking computation. And so then within the stream itself, it kind of had an update statement as well. So each stream's kind of taken up like 2 like concurrent like operations. So when you had a second, there was like this competition for threads, and randomly one of the threads would drop. And so then the Slick Producer was kind of initiating this onComplete method, which then went up the thread. So giving it those more threads and kind of managing it better is kind of like solve the issue. So then from here, it's like after digging into Akka loads, and kind of we tend to have a bit of both FS2 and Akka Streams within our current stack. But like, how does it work in FS2? Like, if I come across the same issue, like how that works, how do I solve it? Especially around back pressure, because that's a lot of what it was. Like, what I thought it was like maybe it was back pressuring incorrectly. And so as you've got like Akka, which has this like graph as a description, and then Akka materializer as the runtime, this can kind of be like streams work very differently. And so where Akka, you've got this like requesting for entities to process, and then the publisher pushes them. With the FS2 model, you have these kind of like stream components, which kind of have these sequence of like lazily evaluated IOs or tasks or whatever they are. And because they're lazily evaluated and the subscriber pulls them, you kind of don't need to solve for back pressure, because it's just naturally pulling them from the publisher. So it's kind of like it's just given for free. And then also kind of like comparing the interoperability between Akka and FS2, I would say like Akka adheres to Reactive Streams contracts. So any sort of Java-based API, any sort of database implementation, like can just easily, if it like has Reactive Streams, then you kind of know the common language, and then you can like use this publisher, subscriber, processor model, and just kind of connect it to a big chain. With FS2, it's kind of just like given for free from the type level stack, so it kind of just works out of the box well with like the CATS ecosystem, and just knowing the abstraction of like the classic flat map, you can just kind of compose them all, and just compose them by having this your normal kind of functional composition. However, FS2 also has a submodule which implements a Reactive Streams contract. So if you do need to interact with any sort of like Java-based API or like anything in like not in that universe, then you can kind of like easily just connect it using like the Reactive Streams kind of submodule project. Cool, and that's my talk. Is there any questions? Okay, we're going to test this out. Alright, got it. It takes 10 seconds to come on.
Cool. So I had a few curiosities about how you use Akka, because you described Akka Streams at a very high level. I was curious about how often you use that graph DSL thing, because as far as I've seen, the graph DSL is probably used once or twice in the critical components when you direct flows of data to and from the main components, and there's a central piece that basically almost visually describes the interaction between components. I was curious how often you use that.
Yeah, so that is just like the high level components, and then like as you saw in that part, there was something called a throttled search, and then underneath that is where you have like, but that's where you kind of have, you can come away from like the Akka Streams DSL and not worry about it, and then just use like plain futures under the hood and just kind of concurrently deal with it over like whatever you want that to be. So kind of, yeah, the way it was used is just to have like kind of your components around the main faults, like things you want to like have within the stream and parallelize or have like kind of control over, and then underneath that like throttled search thing is like you just had like a big long like futures flat map.
I was curious about how many of those graph DSL instances you use, or you just use one or two just to communicate between components.
What within that? So that was kind of like an exact replica of what it was. So it was about that many. Yeah.
How about the graph? Akka Streams offers this very in-depth, low-level API, the graph stage. Do you happen to create your own components?
No, I don't think we have. No.
Okay, cool. Third curiosity: do you use clustering in tandem with Akka Streams?
So when trying to scale it, like I always look at whether to use clustering. I think it kind of, for me, instantly, because we have like kind of abstraction over like how we interact and how we like scale our like services horizontally and stuff, that it seems like it needs to be like implemented on that level. So it seems like it needs like some extra configuration which would like require like SRE and like our like kind of like DevOps team to like help support. So what we went for was kind of like having a lock system within the database to scale and kind of have multiple services kind of communicating through the state within the database to scale it rather than scaling it through kind of Akka cluster. So yeah, I looked into it, but it seemed like it needed a lot of like extra kind of abstractive work in order to implement it.
So a bit outside of Akka, the scaling part.
Yeah.
Got it. Good. Thank you.
Cool. Thank you. Any other questions? Yes.
Okay, yeah, so I haven't used the Akka ecosystem, but I know there's, I'm using FS2 at work, and there's some good integrations with, for example, Kafka or RabbitMQ. There's like bindings for, you know, Kafka consumer or producer to FS2. So I don't know, I was wondering how you do that from Akka, because Akka Streams seems like, you know, building block for maybe other integrations. Like, do you have, let's say, a Kafka consumer written with Akka Streams or something like that?
I actually don't know myself. I haven't had to work with Kafka in my day-to-day, so I haven't looked for libraries, but I'm sure there is.
Or, you know, RabbitMQ or something.
There's a Akka that allows you to interact between Akka Streams and various other components. Akka, Kafka, RabbitMQ, that sort of stuff.
Yeah, there's quite a few. I'm looking into it at the moment, and there's the library that I'm using for FS2 also plugs into Akka Streams. It's like one of the other options. So it's really interoperable.
Any other questions?